Okay, before to continue, let me clarify terminology and symbol. Okay, the most important symbol is this symbol, que is the integral sign. Look like an elongate S. Was introduced by Lenin in 17th century. Now, normally the function inside f of x is integrand function. A and b are the limit of the integration, and normally a is the lower and b is upper limit. Dx is no official meaning by itself, but together with the rest of the symbol is like one complete symbol, is all like a one symbol. And the procedure to compute the integral is called integration. Okay, one important theorem is necessary to understand. If f is continuous on the closed interval a comma b, or if f is only a final number of the Young discontinuum on the interval a comma b, of course, then f is integrable on a comma b. That is synonymous to say that is the defined integral exists. Okay, let's see the guideline by computer defined integral using Riemann-Sum. Okay, step number one is calculate delta x, and the formula is b minus a over m. Okay, the second step is compute or find x sub I is equal a plus I times delta x. The second or the third one is evaluate f evaluate sub I f evaluate sub I f sub I. The fourth is evaluate the multiplication f x sub I times delta x. Number 5 is evaluate S sub m is equal to the summation and the I starting 1 to m of the product f x sub I times delta x. In this part, normally we are using sum laws. Okay. Now, and number 6 step is finally compute the limit when the n approaches to infinity of p sub m, and see this limit exit is equal to the defined integral. Let's see example to understand much better this idea. Okay, some law that we use in this problem is, for example, when you have the summation, the one constant is just the constant multiplied by m, because the upper limit of the summation. When you sum the m natural number, is this formula. So this formula, and let's square, when let's cube it, we studied in pre-calculus class, and we can prove very well using mathematical induction. Okay, let's start this example to calculate this integral. It's the same integral we start this lecture using Riemann-Sum. Remember step number 1. Step number 1 is compute delta x. The formula is b minus a over m. In our problem, b is 4, minus 1 is a, upper limit minus lower limit divided by m. The answer is 3 over m. The second is complete expression for xi. Xi is a plus I multiplication delta x. A is 1, I is a variable, and delta x is 3 over m. This is much better to write 1 plus 3i divided by m. Okay, now number 3 is evaluate f and x sub I in our function, que is 1 plus 3i over m squared minus 4 multiplication 1 plus 3i over n plus 5. Okay, now basic algebra. FOIL or quick FOIL here is 1 plus 6i over m plus 9i squared over n squared minus, distribute the property here, 4 minus 12i over m plus 5. And we combine later, so we have 9i squared over n squared stay, and minus 12 and positive 6 is minus 6i over n plus 1. No, plus 2, because it's 1 minus 4 is negative 3, and negative 3 plus 5 is plus 2. Okay? Okay, step number 4 is evaluate f of x sub I times delta x. F of x sub I expression is 9i squared over n squared minus 6i over m plus 2 times delta x 3 over m. Now this expression is multiplication is 27i squared divided by n cubic minus 18i over n squared plus 6 over m. And number 5 is evaluate f sub m, que is the summation of this. Summation from 1 to n, the f x sub I delta x. In other words, f sub m is equal the summation for this expression. Entonces, apply the property for the sum, the coefficient C, and the term you do not depending on I is constant and put outside is 27 over n cubic summation I1 to m of the I squared minus 18 over n squared, again summation of I from 1 to m plus 6 over m summation 1 to m of 1. Okay, and using the formula of the summation, we have 27 over n cubic time m plus 1 2m plus 1 divided by 6 minus 18 over n squared times n plus 1 over 2 minus 6 over m times m. Let's cancel this part, let's cancel this part, let's cancel this part. It's 2, it's reduce the lowest term here is divided by 3 is 9, divided by 3 is 2, in this case divided by 2 is 1, divided by 2 is 9. Okay, entonces so far the answer that we have is, okay, after the simplification we have S sub m is equal to this expression. Now finally, last step, just compute the limit when the n approaches to infinity of S sub m. Okay, I want to call in different parts. This is A, B, and C. 3 terms. The first is A, is this. So A is equal 9 over 2. I apply property for the limit. The coefficient you put in the front. Limit when the n approaches to infinity of n plus 1 times 2n plus 1 divided by n squared. Okay, it's 9 over 2. Limit when the n approaches to infinity, and you apply FOIL in the top part. I skip that because it's elementary. It's 2n squared plus 3n plus 1. And remember, the limit when this infinity depending only the leading coefficient. The leading coefficient in this case 2 over 1. So basically the answer is 9 over 2 times 2 over 1 is just 9. Okay, A is equal to 9. B, let's see B. B is negative 9 limited when the n approaches to infinity, the m plus 1 over m. And so because this limit is 1, the answer is negative 9. Okay, so we have positive 9 and negative 9. And C is obvious que es limited cuando n approaches to infinity of 6 is 6. Entonces plus 6. And the answer for our defined integral is, cancels out this and this is 6. Okay, conclusion. The limit when the n approaches to infinity of S sub m is always S is equal to 6 in our example. And this is the value for the integral from 1 to 4 of the function, the original function was x to the 4 power, no, x to the second. X to the second power minus 4x plus 5 dx. Okay, now very fast the confirmation using integration rule. This is the original integral. You separate by using the linear property into integral. You evaluate using the power or identity rule. Is x3 over 3, evaluate between 1 and 4, x2 over 2, evaluate between 1 and 4, and 5x evaluate between 1 and 4. And evaluate and subtraction, the rest is just arithmetic. The answer is 6 again.